All right, a quick word on sets. Sets are lists of numbers, a collection of numbers. So if S is a set that equals 1, 2, 3, 4, 5, and we wanted to say that some other number is in this set, like if we wanted, we could say 1 is an element of S, or we could say 2 is an element of S, or we could say 4 is an element of S, right? But 6 is not an element of S. 6 is not in there. 1, 2, 3, 4, 5. That's all we got up there. So 1 is in it, 2 is in it, 4 is in it, 5 is not an element of S. Now let's see here. We could say that S, we could write the same thing the same way. We're going to say that it's 1, 2, 3, 4, 5. But another way to write that is that you could say S equals the set of x's such that x is an integer, right? An integer, and 0 is less than x, which is less than 6, right? So all of the x's that are greater than 0 and less than 6. Now if you were to change that and write this, like we learned a minute ago about inequalities, so this is all of the x's that are integers such that those x's are greater than or equal to 0 and less than or equal to 6. So this now is a different set, and it looks like this. S equals 0, 1, 2, 3, 4, 5, and 6. Right? Now it's easy to write this when you only have these few numbers here. But it's important to be able to write it. It's important to be able to write it like this, because what if you wanted to write x is the set of numbers x such that x is an integer and x is x is less than 5,272,115. So this is now the set of all integers from 1. It's going to be or all integers. Oh shit! I'm going to put it like this. Right? So now this is all the integers from 1 to 5,272,115. Right? It would be really hard to write every single number. You'd have to write 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, 10, 11, 12. You have to count all the way up, and you have to write them all down. This, now we know how to visualize, how to see and understand what that set of numbers is. So that's important. That's a good thing. Now let's talk about union of sets. Let's say that S is, call it 1, 2, 3, 4, and 5, and T call that, call it 4, 5, 6, and 7. Right? Well, you could say that S union T is the union. This is the union operator, right? It means just tell me all the ones that are in elements of both of these, right? So in this case, 4 and 5, or excuse me, we're gonna, anytime an element appears in one of these, we're gonna take it. So S of union T equals, it's going to be 1 and 2 and 3 and 4. 4 is in both of them, but we don't have to write them both times, we just write it once. And 5 and 6 and 7. Right? So this doesn't have 6 and 7. This doesn't have 1, 2, and 3, but the union of those two has 1, 2, 3, 4, 5, 6, and 7. It's got them all. Right? Now there's another idea called the intersection. So let's go back 1, 2, 3, 4, 5. T is 4, 5, 6, and 7, right? So the S union T, it's a new symbol, union operator. Union T means the elements that are common to both of them. So that's going to be only the ones that are in both of them. In this case, 4. There's a 4 here and here. There's a 5 here and here. But there's no 6 or 7 in this, and there's no 1, 2, and 3 in this. So it's just 4 and 5. Right? And then let's say if we had another set. It's called the set V. And that's 10, 11, and 12. Right? 10, 11, 12 is not in either of these guys. Right? So if you were to try to do an intersection of S and V, you'd get nothing. Because there's no 10, 11, 12 up here in S, and there's not a 1, 2, 3, or 5 here in V. So now we can go on to intervals. We'll do that in a minute.